Welcome to Copilot Podcasts. Imagine shooting a whale with a shotgun, not to hunt it, but to study it. That's exactly how scientists started tracking whales in the 1930s. Today, we're diving into the fascinating evolution of whale tagging technology, from crude metal tubes to high-tech suction cups that beam data to satellites.
You know, it's pretty wild to think about how far we've come. Those early methods would be considered shockingly invasive by today's standards.
Let's start at the beginning. Take us back to those first whale tags.
Well, it all began in 1932 with something called the Discovery Committee. They developed these metal tubes about 28 centimeters long with a lead point and a serial number.
Wait, how did they actually get these tags onto the whales?
That's where it gets interesting. They literally used 12-gauge shotguns to embed these tags into the whale's blubber.
A shotgun? That sounds intense.
It was. But here's the clever part. They actually worked with whalers, offering rewards for returning tags found during whale processing.
So they were basically using the whaling industry to track whale movements?
Exactly. It was a different time, commercial whaling was still active, and scientists had to work within that reality to gather data.
How effective were these early tags?
The data was pretty basic, but it gave us our first real insights into whale migration patterns, though the method was obviously limited by the fact that you had to kill the whale to recover the tag.
When did things start to change?
The real transformation began in the 1970s and 80s. That's when electronic tagging was born.
And that was a game changer, right?
Absolutely. The first satellite tag was attached to a whale in 1983. Suddenly, we could track living whales in real time.
That must have opened up whole new areas of research.
It did, but it also raised new questions about the impact of tagging on the whales themselves.
What kind of concerns are we talking about?
Well, research has shown that some tags can cause tissue damage when the blubber and muscle layers move differently during swimming.
That sounds painful.
It can be. Studies on dolphins have shown that tag sites can develop cavities and swelling.
So how did researchers address these issues?
This led to a series of important workshops starting in 1987, focusing on developing better tracking systems and understanding their effects on whales.
And that brings us to modern methods?
Yes, now we have amazing non-invasive options like suction cup tags.
Tell me more about these suction cup tags.
They're incredible, about 20 centimeters long, hydrodynamically designed, and they just stick to the whale's skin temporarily without causing any harm.
Like a little whale backpack.
That's actually a great analogy. And these tags can collect massive amounts of data about movement, diving behavior, and even the sounds whales make.
How long do they stay attached?
They typically stay on for hours to days and then just fall off naturally.
That seems much more whale-friendly.
It is. And we're combining these tags with other technologies now, like passive acoustic monitoring.
What's passive acoustic monitoring?
It's basically listening for whales underwater. We can track their movements by picking up their vocalizations.
So we're eavesdropping on whale conversations?
In a way, yes. And it's giving us incredible insights into their behavior and migration patterns.
How does this help with conservation?
It's crucial. When we know where whales are in real time, we can alert ships to avoid collisions and protect critical habitats.
That's amazing progress from the shotgun days.
It really is. And the technology keeps improving. We're now using GPS and cellular networks for even more precise tracking.
Like whale cell phones?
Sort of. A recent study actually used GPS and GSM technology, the same system used in fleet tracking, to monitor humpback whales.
Did it work?
Yes, surprisingly well. Since many whales migrate close to shore, they're within range of cellular networks.
That's incredible. What's next for whale tracking technology?
We're seeing more integration of different technologies, combining satellite tracking, acoustic monitoring, and even drone surveillance.
Drones too?
Yes, they're becoming an important tool for observing whale behavior from above without disturbing them.
It's amazing how far we've come from those first metal tubes.
And it's not just about better technology, it represents a fundamental shift in how we study and interact with these magnificent animals.
What do you mean?
Well, we've moved from invasive methods that prioritize data collection over whale welfare to approaches that respect these animals while still gathering crucial information.
That's a really important point.
It reflects a broader change in our relationship with marine mammals, from exploitation to conservation.
And better data helps with that conservation, right?
Absolutely. The more we understand about whale behavior and movement patterns, the better we can protect them.
What's the biggest challenge now?
Balancing our need for data with minimal impact on the whales. Even with non-invasive methods, we need to be thoughtful about how much we interact with them.
It's like the observer effect in physics. Sometimes studying something changes it.
That's a perfect analogy. We're constantly trying to find that sweet spot between gathering valuable data and minimizing our impact.
As we wrap up, what's the most exciting development you see coming?
I think it's the integration of artificial intelligence with these tracking technologies. We're getting better at predicting whale movements and understanding their behavior patterns.
So we're not just tracking where they are, but predicting where they'll be?
Exactly. And that could be game-changing for conservation efforts.
From shotguns to AI, what a journey.
It really shows how far we've come in our understanding and respect for these incredible animals.
Well, that brings us to the end of today's episode of Copilot Podcasts. From crude metal tubes fired from shotguns to sophisticated suction cups that beam data to satellites, we've seen how whale tracking has evolved alongside our growing commitment to conservation.
And remember, every advance in tracking technology brings us closer to understanding and protecting these magnificent creatures for future generations.
Thanks for listening, everyone. Next time you hear about a tagged whale, you'll know just how far we've come from those shotgun days.
Putting tags on whales is both exciting and difficult. The method we use to attach tags to whales was pioneered by Dr. Bruce Mate here at OSU and was developed over several decades. We obtained special permission from the federal government to approach whales closer than 100 meters and to attach our tags. This involves an extensive permitting process that has to be reviewed every 5 years to ensure that it meets the best practices to minimize any impacts on the whales. Tags are deployed using an air-powered applicator. An orange deployment tube holds the tag in the applicator. Once the tag is attached, the orange tube is released and floats to the surface for recovery. We assess a whale's body condition and behavior from a distance before deciding if we want to attempt tagging it. We then approach carefully from behind and to the side. The tagger has the best view and helps direct the boat driver using a headset radio. The tags can't transmit to the satellite through water, so we try to attach them high on the whale's back so that they always come out of the water when the whale surfaces. At the same time, we also collect a small skin and blubber sample using a crossbow to determine the sex, genetic relatedness, and population identity of tagged individuals. We also collect photos of each animal for identification purposes, using their distinct markings. Once a tag is attached, we record the time, location, and a variety of information about the placement of the tag on the whale to help with future monitoring efforts. What happens next? After the fieldwork is done, we go back to the lab and continue monitoring each tagged whale for weeks and months through the information relayed to us by the Argus service until the tag eventually falls out.